Alright, in this video we're going to talk about some common errors that people make, and hopefully by talking about them you will not be one of those very frustrating people who makes these errors all the time. As a teacher, people making these errors gets really frustrating because you tell your students all the time, hey, this is not true, you can't do this, you're not allowed to do this, and then people still try to do it, right? So the key thing here, and a lot of these, if you watch the other videos that I've done, we've already talked about a lot of these things. Actually, pretty much all of the ones that are on here we've already mentioned here and there. It just kind of puts them all together here to talk about all at once. The key thing is, some things you can do when there's multiplication involved, you cannot do when there's addition involved, right? And that's kind of the key difference between these things that you are allowed to do and the things over here that you're not allowed to do. All of these involve multiplication. All of these involve addition. You can do these things with multiplication. It doesn't work with addition, all right? All right, so the first one is a times b raised to the second power, right? If you have something in parentheses raised to a power, it doesn't have to be the second power. It can be raised to any exponent. You can distribute that exponent into the parentheses when you have multiplication within the parentheses, right? That equals a squared times b squared. All right, if you have a plus b in parentheses squared, that is not equal to a squared plus b squared, right? Remember, a parentheses squared means a plus b times another parentheses of a plus b, and then you have to do the FOIL method to actually multiply it out, and you get more than just a squared plus b squared, right? So distributing an exponent into a parentheses is okay with multiplication or division. It's not okay with addition and subtraction, all right? Same idea when you have a root, right? The root of a times b is equal to the square root of a times the square root of b. And again, it's not just for a square root, for any root here. It could be the third root or the seventh root. It doesn't really matter. If you have multiplication inside that root, you can split it up into two separate roots of those two things individually, right? It works with multiplication. It doesn't work with addition. The square root of a plus b is not equal to the square root of a plus the square root of b, right? Those two things are not equal to each other. All right, so again, you can do it with multiplication, you can split it apart, you cannot split it apart when there's addition in there. All right, the square root of a squared times b squared equals a times b. All right, so if you have the square root of two things that are being multiplied and both of those things are perfect squares, you can take the square root of each one of those things and just multiply them together to get your result. All right, so that works with multiplication, but with addition, the square root of a squared plus b squared is not a plus b. Right? If you have addition in here, you can't just take the square root of a squared and the square root of b squared to get a plus b. It does not work that way. All right? Fractions, right? If I have 1 over a times 1 over b, if I'm multiplying two fractions, I just multiply straight across. That's 1 times 1 gives me 1, a times b gives me ab. That's my result. Right? When I'm adding fractions, 1 over a plus 1 over b is not equal to 1 over a plus b. Right? When I'm adding two fractions, I don't just add the denominators together. Remember, to add two fractions or to subtract two fractions, I need to have a common denominator before I can put those two together. Right? So this does not equal just 1 over a plus b. Right? This one over here, ab over a, right? Remember, when I have a fraction, I'm trying to simplify it. If I have multiplication in my numerator or denominator, and there's a common factor in the top and bottom, like in this case there's an a up here and there's an a up here, those a's can cancel out and it just leaves me with a b, right? But when there's addition in the numerator or denominator or subtraction there, a plus b over a, in this case the a's do not cancel out to just give me b, right? I can only cancel out the stuff in the numerator and denominator if they are factors, if they are being multiplied by the other stuff in the numerator or denominator. If they're being added or subtracted, I can't just cancel stuff out. Right? These things on this side, it'd be a lot cooler if those things did work because it would make our lives a lot easier. Like if I saw a plus b over a and I had to simplify it, I can just cancel out the a's and that equals b. Well, that would be really convenient, but it's not mathematically accurate. You cannot do those things, no matter how nice it would be if it worked or how easy it would be if these things worked. A plus b in parentheses squared, that's not a squared plus b squared. You can't just say, well, I wish it was, so let me just write it down. It's going to be wrong every time you do that. Right? So these are the common mistakes people make, and like I said, we've already talked about a lot of these. If you watch the other videos that I've done, I've mentioned pretty much every single one of these. Maybe not this one in the middle here, but that's kind of related to the second one. All right, so things you are allowed to do with multiplication, you are not always allowed to do those things with addition or subtraction. Right? Now, if you do need to do something like that, like if I do need to simplify a fraction, but I have addition here, Well, I can only simplify it if I have multiplication. That's where factoring comes in. Remember, factoring creates multiplication. It's this thing times this other thing, and if I have two things multiplied together, now I can cancel stuff out, right? Or if I have two things multiplied together, now I can separate those square roots, right? So a lot of times if you have these things that involve addition and you need to simplify the fraction, or you need to, simplify the square root, what you do is you try to factor it so that you create that multiplication there, and then once you've created the multiplication through factoring, then you're allowed to use these properties on the left side up here to actually simplify stuff and kind of proceed on with the problem. So that's one of the reasons why factoring is such a useful tool, is because it can take you from addition, like we have up here, and take you into multiplication, where then you're allowed to actually do these things and do the simplification, right? So factoring is a major thing, and in some of the problems that I've done in some of the other videos, I've mentioned that and kind of showed you how that works. So factoring is important. So if you're trying to simplify a fraction or simplify a square root, and you're like, well, I know I cannot cancel these out since I have addition here, what can I do? Try to factor, right? If you're able to factor it, you might be able to cancel stuff out and simplify. All right, so those are the common mistakes. These 5 things up here, please don't do these things, right? They're not correct, and they make your teachers very mad when you do those things. So try to avoid doing those at all costs. All right.